Thanks a lot, Kirk. Welcome, everyone, and thanks for joining us today. We're going to, as Kirk mentioned, we're going to talk about a different component of the toolkit than perhaps many of you are familiar with. We're going to spend a lot of time talking about the Cozy Launcher and how to run remote processes to enhance your ZOS workload. So let's go ahead and get started. Before I talk about the launcher, I've got some introductory work to do here. I want to you've probably already seen this chart many times if you've been on our webinars before, but I want to kind of give you a rundown of who we are and what we offer. Our mission statement is that we want to provide ZOS customers worldwide with innovative solutions that enhance and transform traditional mainframe workloads. To do that, we have our flagship product, the Cozy Co-Processing Toolkit for ZOS, which we're going to talk about today. We recently announced a new product called the OpenSSH Accelerator for ZOS, which is a product that allows you to dramatically reduce the amount of CPU that your Ported Tools SSH product uses on ZOS. We'll talk about that briefly at the end of this conversation. We also offer a Tomcat solution for ZOS called TZ, which is a way to install and get Apache Tomcat up and running on ZOS very quickly and set up a nice little web serving environment. And for those of you who aren't familiar with our history, we were the original authors of the JZOS toolkit back in 2004, which was acquired by IBM and now ships as part of the ZOS Java SDK. Okay, let's talk a little bit about the Cozy Co-Processing Toolkit components. I want to do this as by way of introduction to kind of lead you into how the launcher works. So there's going to be a little bit of preparatory work to start. At the very core of the Cozy Toolkit is a reusable record streaming library that we've written. And this is effectively a sort of, if you think about it, it's a Swiss Army knife set of tools for converting between ZOS data sets and POSIX-style streams, POSIX-style streams that can be read through pipes and written to POSIX files. So there's all kinds of different options that are available for doing code page conversions and doing line termination control, all that sort of thing. So that's at the core of the Cozy toolkit. Cozy SFTP is probably the most popular component of the toolkit, and perhaps one that you're familiar with. What it does is it basically enhances the SFTP offering from IBM through the Ported Tools OpenSSH product, and it allows you to transfer ZOS data sets as well as POSIX files. In addition, we support SMF recording, and we handle FTP-style exits if you have them and you want to make use of them. So that's all available with the SFTP component in Cozy. Cozy Batch is, simply put, a better version of BPX Batch, which is available from IBM for running Unix shells in a batch environment. We're going to talk about that and show an example of Cozy Batch in just a little bit. Cozy Dataset Pipes is a set of command line utilities, two of which are very important for the Cozy launcher, called from DSN and to DSN, but there are other utilities as well, namely being able to write WTOs, working with system symbols, and so on and so forth. But at its core, Dataset Pipes is basically the command line facilities for converting data sets to streams and streams back to data sets. The component we're going to focus on today is called the Cozy Launcher. And what it is in a nutshell is an ability for a ZOS batch stream to launch a remote process on a remote system and distribute the application and data processing on that remote system all within the context and control of a ZOS batch job step. And in order to make that work, along with remote dataset pipes, you'll need one more component from the COSI toolkit, which is called the Target System Toolkit. And this is software that's installed on your remote system, and it's available in binary form from our website for Windows and certain variations of Linux. And it's also an open source package, so you can take the source and build using typical GNU build techniques to build an executable that will work on almost any POSIX platform that you have. Right, let's talk a little bit about the synergy between these components in the toolkit to kind of get a sense for how they all work together. SFTP, dataset pipes, and the COSI launcher all make heavy use of this reusable record streaming library that I discussed early on. So that code is deeply entwined with the three major components of the COSI toolkit. COSI batch is used on a ZOS system in a local processing fashion to be able to run local dataset pipes jobs for converting datasets to streams. And it's also used by a lot of our customers to script SFTP client jobs using COSI SFTP to allow for the sending of datasets and receiving of datasets to remote systems using the OpenSSH SFTP protocol. The Target System Toolkit, which I just discussed, allows you from a remote system, say a remote Linux system or a remote Windows box, to initiate a request to a ZOS system using a dataset pipe command to read a data set from your ZOS system and then write it to your remote system that you're working on. And the COSI launcher takes that a little bit, that a step further, and allows your remote job that's running inside of your, in the context of your job step, to use these dataset pipes commands to reach back into your job step and read DDs and datasets from your ZOS system so that they can be processed remotely. And we're going to show some really good examples about how that all works and how it's all configured. But finally, we have an ability to hook up both the launcher and SFTP to keys, public and private keys that are stored in a RACF/SAF certificate system. So you can look at our documentation to get more information on that. Okay, so to start this discussion about the COSI launcher, I want to first describe how COSI batch works, because this will provide a nice contrast to what goes on in a launcher environment. So what COSI batch does is it allows a user on a ZOS system to run a Unix command or a shell script in the context of a batch job step. The exit code from that shell script is then adopted by the job step as its return code, which can be useful for handling step-to-step processing. The standard out and standard error DDs in the job step handle the standard out and standard error from the Unix shell, and that can be output to either a dataset or to a Unix system services file on your systemz Unix system services file system. Unlike BPX batch, the standard in DD card can be used to provide input to your shell, and with our COSI batch, the shell that you launch is actually a login shell, and it's run in the same address space as your BPX batch job step, so that you can access any DDs that are defined and available to that job step. So that's one of the differences. Let's take a look at the next component that we're going to be looking at today in detail, dataset pipes. As I mentioned earlier, there are two primary commands, from DSN and to DSN, and these are used to respectively read datasets and write the contents of those datasets to standard out, or to read from standard in a stream of data and create a dataset from that stream. That's what the to DSN command does. Dataset pipes can be invoked in one of three modes, either locally on your ZOS system, either in a batch job using COSI batch, or from your systemz Unix System Services command line. You can actually invoke these commands locally. Dataset pipes can also be run remotely or remote initiated from a remote system that has the target system toolkit installed, and you use SSH as the transport to receive and send the data from the datasets. And finally, and what we're going to focus on today, dataset pipes are used extensively inside of a COSI launched remote process to access datasets from within a job step. And as I mentioned earlier, there's a whole Bible of extensive dataset conversion options that are available. And we're going to show some examples of some of those options, but you should consult the manual for a complete list. Okay, so here's our first baby step in getting ready to talk about the launcher. We're not going to actually be using the launcher here, but we're just going to simply be using COSI batch to run a local Unix System Services login shell to run a very simple shell script. So as you can see, we have our standard out and standard error from the shell script. They're going to end up going to sysout. And our standard in, which is an inline DD, contains the shell script that we wish to run. So the first line of this shell script is a comment, and it basically tells us that we're going to be running locally under the ZOS Unix System Services set of libraries. The next line issues a command, our command from DSN, which reads the dataset member, the partition dataset member ACB from the dataset sys1 maclib. It takes that dataset as input and it writes it to standard out. The vertical line that follows is the pipes, this Unix pipe symbol. So it writes standard out to a Unix pipe, which is then routed to a Unix System Services command called sed. What sed is it's a stream editor, and it's a little utility. It's very useful in Unix that will allow you to read a stream of data and process it sort of inline as you're reading it. So what this little simple sed script does is it looks for any line that begins with a dot followed by an asterisk, and it issues the delete command on that line. So effectively what we're doing is we're reading this ACB member, and we're going to strip out any comment lines that exist in that member. Well, sed is just a utility, a normal Unix utility, so it takes its input and it writes to standard out like any good Unix utility will do, which we then pipe using the pipe command to our 2DSN, which is running locally on ZOS, and 2DSN takes the output from sed and writes it to the output DD, which we've defined in our job step here, as a temporary data set that we're going to pass on to the next job step. So in effect, what this little tiny shell script does is it allows us to use from DSN, sed, and 2DSN to read a member from a data set, strip off the comment lines, and then pass that data set on to the next job step for processing. It's very straightforward. Okay, so here are a couple of more complicated examples using some of these dataset pipes utilities. This first one takes its input from redirected file on our ZOS Unix System Services POSIX file system located at home user file. It takes that and it streams that file into a data set on our ZOS system called MVS1 output data set. Very simple. The next example runs the Unix utility processor status with a couple of arguments and takes the output of that command, pipes it to our 2DSN command, where we allocate a new data set with this DCB information, recfm equals FB and LRECL equal 80, and we create a new data set on our ZOS system called myDSN. So it's effectively a way to take the output from a Unix command, processor status, and write it to a data set that we can deal with later. Next example echoes a line of text to 2DSN, where we use the append option, and we append that line to an existing data set called log.data. This next example is kind of interesting. It is a sort of a quick and dirty way to perform an EBCDIC to ASCII translation of a data set. So we use from DSN to read a data set, a DD card in particular, that's in EBCDIC, and pipe it to the toDSN command, where we translate the data, that's the -T, we want to translate to the code page ISO 8859. So toDSN takes its input from the EBCDIC data set and converts it to ISO 8859 and then writes its output to a new data set identified by DD ASCII. So if you ever wanted a quick way to do a conversion within data sets, you can use this, this sort of form. This last example, without going into too many details, reads a binary data set and writes to a Unix file system file on ZOS with embedded record descriptor words to allow you to distinguish one binary record from the next. Okay, here's some from DSN examples. This from DSN command uses the bpxwdyn share keyword to allow us to use a disp equals share to read an MVS data set and pipe and redirect the output, which goes to standard out, to a file on our local ZOS Unix file system. This from DSN command in the next example reads some input data from a data set, pipes it to the Unix grep utility, where we look for a string, any record that starts with the letters capital A followed by the number 1, and then we take those records and we write them to a new data set, which we call filter.data, using another bpxwdyn option. And finally, this here's a fairly complicated example where we run the Unix utility netstat, and we write the output of netstat to sysout using a series of bpxwdyn options. Okay, so those are this is the idea to just sort of familiarize you with how from DSN and toDSN work in local mode, that is on a single ZOS system. Okay, well, suppose you're not satisfied with that and you'd actually like to be able to read and process data sets from a remote system. Well, you can do that using the same commands from DSN and toDSN, which are part of our target system toolkit. And the way you invoke the commands on those remote systems is you just supply another option to say use SSH as the transport. Here's the user ID that I'm going to have on my ZOS system, and this is the ZOS system that I'm going to connect to. So you just add this -SSH option to be able to run these commands remotely. And so this example simply reads, as the earlier one did, from an input data set. But now the standard out from DSN is not going locally to ZOS, but it's actually coming across SSH to your remote system, where you're going to redirect that to a file on your remote system called mydata1.txt. Okay, this is a toDSN example that takes a remote system file in the directory var logs called mylog, and it routes it using SSH to a data set on your ZOS system called myDSN. Here's an example using SSH to transfer a binary file with record descriptor words involved. And this last example is kind of interesting. It shows a way for you from a remote system using toDSN to take some JCL that you have in a file on your remote system and submit it to the internal reader on your ZOS system. So it's kind of a handy little utility for doing that. Okay, so this is all lead up to our main discussion today, which is the Cozy launcher. What the Cozy launcher does in a nutshell is it allows you to launch a process on a remote system from within a batch job step using an SSH connection. Input to that remote system is redirected from the DD card standard in, and output from that remote system is redirected back to ZOS to the standard out and standard error DD cards inside your job step. And this is also important. The remote shell, that is the shell that runs on the remote system, its exit code is adopted by the Cozy Launcher as the job step condition code. And remarkably and excitingly, the to DSN and from DSN commands can be used from that remote process to, in effect, reach back into your running job step to access that step's DDs and any data sets that you have access to on your ZOS system. You're going to see that this is a fairly powerful mix of components that allows you to do some really interesting and useful things using remote systems. In addition, the Cozy Launcher also has some console commands that allow you to monitor, control, and send input to the remote process that you're running. Okay, so let's take a look at an example. This should look familiar to you. In fact, it's the identical chart that we showed earlier using Cozy Batch, with only a single change to the Cozy Batch example. Instead of calling Cozy Batch, we're going to invoke the Cozy Launcher, which is actually contained in this proc called Cozy Proc, and we're going to supply a set of arguments. And the arguments that we supply to the Cozy Launcher are the user ID and the remote system that we want on the remote system that we want to run the shell on. Standard out still goes to sysout. Standard error still goes to sysout. But standard in now, instead of being run locally, is going to be completely shunted over to that remote system, linux.myco.com, and it's going to run over there on that system. So the eye catcher here is that we've colored this standard in blue text. And when you see this in this example and any other example that we show today, I want you to use that as sort of a mental image that this is a shell script that's running on a remote system, and it's not running on ZOS. It's kind of interesting. So in this case, we took the same shell script. We issue now the from DSN command, which is not the local from DSN command, but the one that's part of the target system toolkit, and we reach back into our job step, and we access the ACB member, sys1.maclib. We pipe that member into the sed command. Well, which sed command is this? It's actually not the sed command on your ZOS system. It's the sed command on linux.myco.com. They happen to both have sed commands, but in this case we're running sed remotely. Sed still does what it did before. It strips off the comment lines, pipes its output to a Unix pipe, which is then picked up by our to-dsn command, which we take and redirect to our output DD. So again, identical examples. The first one showed running this shell script locally, making use of systemz Unix system services. This example uses the Cozy Launcher to take that same exact shell script, not run it locally, but run it onto the remote system linux.myco.com and achieve the same result, with one difference. All of the processing time associated with the sed command is no longer charged to your ZOS system. It's now charged to your remote Linux box. So you can see here our output is a temporary data set that we pass on to our next step. Let's take another look at another example here. Again, colored blue shell script indicates that this is actually a shell script that's going to run on our remote system, linux.myco.com. The first command that we issue from that remote system is we're going to say we're running on, and then uname gives us a Unix name and some additional information about the version of Unix that we're running. And then we perform the following steps. We issue the cat command, which basically writes out a file, syslog.0, which is in the directory var.log. Now, where is this file? This file is on the linux.myco.com machine, and we are using the remote cat command on that machine to dump the contents of that file to a Unix pipe, which goes to our to-dsn command, which is running on that Linux machine, where we truncate long lines, We allocate a new data set using the bpxwdyn like command, like keyword, and we write, using our 2dsn command, that syslog data to a new generation of a GDG that sits up on our ZOS system. In fact, the ZOS system that launched this remote process in the first place. So it's important to keep in mind what's going on here. This shell script is actually running on a remote system, but using the from the 2dsn command, it takes the output of a remote file and it can write it to a data set on your ZOS system. Okay, this next example is actually quite a lot more complicated, but it is here to show you some of the power that's available to you using the Cozy launcher. I want to point out that we're running again here on in this case it's a remote system titled DMZ1, which should give you the sense that it's a demilitarized zone system in your computing complex. And you're going to run this shell script. The first line of the shell script, again running on that DMZ machine, is the wget command, which is effectively a command that will read a file from the internet, in this case the congress.db.txt file, which is located on the remote system, a third-party remote system called ftp.visi.com. And this file contains all the members of Congress with tab-delimited information about their contact information. So we can issue this wget command. This runs on our remote machine. We pipe the results or the contents of that file into another Unix utility called awk. And awk is another text processing, really nice little text processing tool available, where we tell awk that our field delimiters are the tab character, and we're going to define a little variable here called single quote SQ to define the single quote character. And here is, from this brace down to this one, our awk program. And the awk program says if we are working on the first line, that's what this test does, we'll skip it because it contains header information about those Congress members. And we're going to have awk print to print out this line, delete from Congress, followed by a semicolon. Now what does this print do? Well, in awk, when you issue a print statement from an awk program, it will, by default, write whatever you've asked it to write out to standard out. And we'll see what happens here in a little bit. So effectively, we're writing to standard out, delete from Congress. Now, for every subsequent line that comes from this congress.db.txt file, we're going to do what's in the else leg of this awk program. We're going to issue the insert into Congress values, followed by the left paren, and then we're going to print a single quote, followed by $1. What's $1? Well, $1 is the first field from the file that we read. So it's presumably the congressman or congresswoman's name, followed by a single quote, followed by a comma. Then we follow that with a single quote, the second field from that file, followed by a comma, the fourth field, and then the third field. And then we finalize this particular line by writing out a right parenthesis and a semicolon. So think about this little chunk of code being run for every single Congress person in that file, and that output is going to the remote system, dmz.1 myco.com, to its standard out handle. Well, what happens to the standard out data when we're running inside the Cozy launcher? It actually gets filtered and sent back up to ZOS and is by default written out to the standard out DD card inside of our job step. So all of this processing, as we'll see here on the next chart, goes to our standard out DD, which is not sysout in this case, but we define, in this case, a new temporary data set called spoofy_in with some DCB attributes, space attributes, and a disposition. So that's the first job step. It's running remotely to get this Congress information and create SQL statements that we want to execute. Step 2 of our job then runs TSO and spoofy to take that input from our spoofy in data set, which is our SQL that we run, to load a DB2 table that's sitting on our ZOS system. So it's a pretty neat little example that shows how we can couple a remote system to do internet connectivity processing, and then take those processing results, send them back up to ZOS inside of a job step, and then have a following job step that takes that and runs DB2 to load a table. Okay, here's an example that is actually even a little bit more intricate than the one I just showed you, but it again illustrates the power of being able to run these things from a remote system. Again, remember, the blue text tells us that we're running. This is an actual Unix shell script that's running on our remote system. In this case, it's linux1.myco.com. What we do in our remote shell script is we read from ZOS a job step data set in our job called ddtrans1, and we read that data in binary format. That is, we don't want to do any conversion on it at all. We pipe that data set to a Unix pipe, which gets read by the gzip command, which is a compression utility available on our Linux system. So basically, gzip just compresses that binary data as it comes across, and we pipe the compressed data to the gpg command, which takes that compressed data and encrypts it so that it's made encrypted. GPG then takes its output and pipes to yet another Unix pipe where we run a fourth Unix command called curl, which allows us to connect to a remote host and upload that data to a partner that we have for our computing environment. I want to make a couple of comments about what's going on here. First of all, wherever you see one of these pipe characters, if you're Unix savvy, you understand that these pipes work concurrently, so that as soon as I start reading data from this trans1 data set on my ZOS system and piping it through this pipe symbol, my gzip command starts processing. So I don't have to completely read the data from this data set. As long as anything shows up, gzip starts processing. As soon as it's finished doing any of its processing, it writes directly to standard out into GPG, which does the same thing, and so on and so forth, all the way out to the curl command. So we get a really nice set of concurrent processes running, and in fact, it's entirely possible that our remote host is seeing the data on its system before we've finished reading all the data from our data set on our ZOS system. So that's kind of an important point. Another really important point in this particular example is this third bullet down here. Because we're using Unix pipes for everything, the data itself is never written in a temporary file. There's no data in transit file either on ZOS or on our Linux system. The data goes directly from, it's piped directly from our data set ddtrans1 all the way up to the partner with no temporary files. So it's a good security measure. This is an example that we have in an article that Kirk and I wrote for Z-Journal magazine a couple of years ago, and it provides a lot of details on how this works. If you're interested in getting a URL to that article, let us know. Contact us at dovetail.com, and we'll provide you with a URL to that. Okay, our final example today of the Cozy Launcher is one that is of particular interest, at least a category of programming that's of particular interest to a lot of ZOS people, let's put it that way. There's been a lot of interest lately in trying to do statistics package analysis off of the ZOS platform using ZOS data. There's a lot of packages available. Some are more popular than others. For this example, we're going to use a little, it's actually not a little, but an open source stats package called R to do some processing. But I want to point out that as long as your statistics package can do these kinds of things that you see in this example, you can pretty much use whatever you want to make use of the Cozy Launcher and your statistics package on a remote system. Okay, so let's take a look here. We're going to run Cozy Launcher on linux.myco.com, and we have a data set that we have on our ZOS system identified by this DD, and the data set is kirk.lifeexp.data. Here's our Unix shell script that we're running. Again, it's in blue, so we're running this all on a remote system. And there's a little comment that explains what R is going to do with it. It's going to run, it's going to take that inline data, and it's going to run a two-dimensional multiple regression on that data from that data set. So let's take a look at it. Here's our R command, which again is running on our remote system, our remote Linux system. And we're going to basically tell R to read its input program inline from the Unix shell that we're providing. So from the EOB here to the EOB down here, this defines the R program that we're going to run. All right, let's dive in a little bit deeper and look at each one of these lines so we can understand what's happening. My pipe is a variable in R that we defined, and we assign to it the result of the R pipe command. And what the R pipe command does is it says, I want to get my data from somewhere, and I want to create a Unix-style pipe that I can read from. Well, in this case, you can see where we're going to get our data from. We're going to issue a from DSN command. Remember this dataset pipe command that we have, and we're going to say we want to read from DSN, we want to read our DD. Where's the DD? Well, it's up on our ZOS system, and it's actually pointing to this data set right here. We're going to do a from DSN, and we're going to have that pipe be open for reading purposes. That's what the R stands for. That's the first step of our R program. The next step is to define another variable called life, which is assigned the results of a read table command, which reads from the pipe that we created earlier, and it tells the read table command that the first row, or the first row of data, contains header information. So we're going to presumably ignore it. Okay, and then finally, not finally, but the next step is to, once we've read that information into our table called life, we close the pipe that we created earlier, and then we issue a two-dimensional multiple regression call, LM, where we supply arguments of the columns that we want to process, and we say that our data is coming from the life table that we created earlier. And then finally, once we've done that, we assign that linear regression to the variable multilinear fit, and then we issue the R summary command on multilinear fit. Well, this summary command, again, does what most Unix commands do, which is to write its output to standard out. Where's standard out? Well, standard out happens to go to wherever we've defined standard out, our standard out DD on our job step. So having walked through this example, I think now might be a good time. Kirk, are you able to give a little demo of this? Is your microphone muted?
Yeah, that would help, wouldn't it? Thank you. Yeah, I have a cough, so I didn't want to be coughing in over your presentation.
Okay, I'm going to switch over to your screen, Kirk, so we can let you run this. Okay, you should have it.
Okay. Can you see my screen?
Yes.
Okay, great. This is, folks, this is just a 3270 emulator. I hope you can read it okay. Let me pick out the JCL for this. And so here's the JCL. Oh, I have a CD temp in front of this. Otherwise, it's exactly the same as what Steve was showing you. And I'll just submit it. function code is 0. And we'll just bring up all of the data sets in the output. So you can see we've got one called sysout, and this happens to be messages from the Cozy launcher. These might be interesting to look at. The version information. We get a message by default from every from DSN or to DSN command that runs that tells what's going on. So there's a from DSN actually that reads standard in for the remote process. There's one that reads the life expectancy DD, and then there's two DSNs that write standard out and standard error. Notice standard error doesn't have anything, but standard out has 15,000 bytes or 1,500 bytes something. So let's look at standard out. So this is actually the output from R. It's some introductory hello stuff. Then it echoes your program, and then some information. Let me page down and we'll see the rest of it. And here's the output data. So what's actually interesting about R, I think, is that this mypipe command allows you to just kind of within R run a command, which in fact the from DSN command allows you to, from within environment, to reach out and grab data on ZOS using this facility that we have. Other packages have the same kind of thing, and I guess I'll say that we've kind of hinted at it, but a lot of our customers are using, or I'll say several of them are using SAS successfully in this environment. SAS has a really nice facility for doing pipes. In fact, you can kind of have your same code that you had running on ZOS, and you just wrap it in a macro that converts the in-file statements from reading DDs to reading from pipes kind of automatically without changing the code. It's pretty cool. So I don't have anything else to show there unless anyone has a question. I don't see any questions. Okay, Steve, so I'll hand it back to you.
Okay. Okay, thanks, Kirk. That's a nice live look at how this example actually runs using the Cozy launcher. Okay, I want to spend a little bit of time talking about performance. And if you've been paying close attention, this is probably one of the first questions that has cropped up. How does it work? How does the data transfer performance hold up? Well, by default, the data connections for the remote from DSN and to DSN commands are, of course, tunneled across your existing SSH connection. And that's very helpful in the case where you're on a remote system where you are actually not in a secure environment and you want to make sure that your data is encrypted. So that's all good. Unfortunately, one of the problems with encrypted data is that it can take time to do the encryption and decryption. So the Cozy launcher can actually operate in two different modes to allow for data connections either to be done through SSH and encrypted, or if you happen to be on a secure network, you can configure Cozy launcher to send the data over a clear channel socket. That is, the data itself is not going to be encrypted, so you've got to make sure you're inside of a secure computing environment. But if you are, you get a couple of nice, really nice option benefits. One of which is the new being able to exploit the new IEDN, or the Intra-Ensemble Data Network, available with these ZBX extension cards available with the new versions of IBM's machines. And so if you think about it, think about a blade that you have set up running AIX, and your ZOS system can then launch a remote process on your AIX blade, and you can use the IEDN to transfer data back and forth using from DSN and to DSN. In addition, without even having one of the new IBM machines, if you have a Linux for System Z on an IFL somewhere in your environment, you can use a hypersocket, which is an in-memory pipe, to communicate between ZOS and Linux, and you get absolutely screaming performance if you're able to do that. And again, in the case where you're actually required to encrypt and secure your data, and you need to use SSH to do that, we encourage you to consider looking at our OpenSSH accelerator for ZOS, which is a way to dramatically reduce the amount of CPU required to perform these data transfers. We'll talk about that in a chart a little bit later on. Okay, so here's an example of the Cozy launcher where we make use of a clear channel. So I'll draw your attention to the Cozy CFG DD, which is a way to configure Cozy itself. And all we do is we tell Cozy, don't tunnel over SSH. So we set the SSH tunnel variable to false, and then all of our subsequent data connections, that is the from DSN and to DSN commands, are going to occur over raw sockets rather than being tunneled back through the SSH channel that we've established. So in this case, this is a little example where we read unloaded SMF data from a DD, which we defined earlier, and we RDW enforce it in the data, and we pipe it to a little program on our remote system called SMFP, for example, which will process that data and do whatever we want with it. But that processing, again, remember, we're in light blue here, so all of this processing is taking place off of ZOS. It's actually taking place on our remote system, in this case, linux.myco.com. I want to take a step back and also point out something I didn't mention earlier. This user ID, the user ID that I actually have for running this job step, these are the credentials that I'm going to be given when I want to reach back and read data sets. So as long as the user running this job has access to this data set, I can do it. If I don't have access, then we'll get an accessing failure. So it's we use RACF or SAF as appropriate based on the user ID running the job itself. Okay. Now on the back end, at the very end of the chain, our tool chain, we have this thing called the Cozy Target System Toolkit. And again, this is that open source little component of the coprocessing toolkit. It's written in portable C++, and it contains the commands to DSN, from DSN, and the Cozy agent, which is what we end up launching on the remote system, which is kind of a gatekeeper for that remote process. So let's see, Kirk's just asked me a question here. Right, yes, this is a good distinction to make. If you're running just the SFTP component of the Cozy Processing Toolkit, you do not need to have the Target System Toolkit installed, right? So just to avoid any confusion. You only need the Target System Toolkit if you want to run the Cozy launcher or if you want to do remote dataset pipes commands that we were discussing earlier. Okay, this toolkit is available from our website. You can download them for free, use for free. There's a Windows package. We have some Linux packages that are available for different architectures, currently both Intel 32-bit and System Z 64-bit. And we have a binary for AIX power, which we've tested and run on a ZBX Model 2 blade. So we've actually got working examples of the Cozy Toolkit and launcher on one of IBM's new systems, and it performs beautifully. We also have binaries available for Solaris if you're interested in those. If you don't see your platform that you're interested in here, you can download the source directly and use the standard GNU configure, make, install process to very easily build an executable. This is not, the intelligence in this code is not overly complicated on this end of things, so it doesn't use a lot of esoteric system calls, so there's a pretty good chance that you'll be able to build and make this utility on your system as long as it's POSIX compliant. Okay, so let's take a look at a picture of the current state of play without discussing IBM's new hardware. This is how the Cozy launcher overlays and works with your existing computing environment. On the right-hand side, in the sort of plum color, we have your System Z, your ZOS KEK, if you will, your System Z KEK, which is running probably ZOS, has to be running ZOS somewhere, and maybe running some IFLs with Linux as part of your System Z ecosystem. You can use the Cozy launcher. Again, this is a graphic representation. The Cozy launcher inside of a ZOS batch job step to launch a remote process on one of these IFLs, and here's our target system toolkit running on Linux to send data back and forth using hypersockets in the case that we have hypersockets available. Conversely, if we want to communicate with a system that's running remotely, that's not part of our System Z ecosystem, we can use SSH to transfer our data. Performance is not quite as good, but it is secure, and it allows us to do remote processing on data that we have on our ZOS system. So this is the current state of play. Now, before we talk about the new architecture from IBM, I want to share with you a somewhat interesting and fairly dramatic success story we had with one of our customers. They started out and they were generating PDFs from XML source, which is actually in a data set on their ZOS system, and they were doing this inside of a batch job using ZOS Java. And the ZOS Java is using an open source framework called iText to convert from XML to PDF format, and it's a fairly intensive process. They were getting about 60 documents a minute on their existing 2094-405 machine workload, and they were running into trouble because they weren't able to process as many PDFs as they needed to. So as a first step, they added a zip running in ZAP mode on that system, and just by doing that and running Java there, they were able to get up to about 80 docs a minute, which helped some, but was still not really where they needed to be. They took a look at our toolkit, which they've been using for some other reasons, and they discovered the Cozy launcher. And they realized that with the simple JCL change, just instead of running Cozy batch, they ran the Cozy launcher. They were able to use their hypersocket connection to their Linux IFLs. They turned on clear channel transmission because they were running inside their own hypersocket system. SSH tunnel equals false, and this is really a shocking number. I mean, we just still chuckle about this. It's really, really exciting. They went from 80 docs a minute to over 900 docs a minute, an order of magnitude, using the Cozy launcher and offloading this information using hypersockets to their IFLs. So they were absolutely ecstatic, and they've been very, very happy with this result. They did have one little glitch that we'll share with you here. The first night the job ran, their operator canceled the job. And they canceled it, turns out the next morning when they're talking to the operator, they canceled it because the job step wasn't using any CPU time. Well, it wasn't using any CPU time because all the processing was occurring on their IFL, and the job step was just sitting idle waiting for the processing to complete. So these programmers had to change their Java program a little bit, where they added some progress messages from the Java program so that they would show up periodically in the sysout spool, so that the operators could see that actually something was going on and the step wasn't hung. So let that be a caution. If you decide to use the Cozy launcher, you might have to have some keep alive messages to keep your operators in check. Okay, so here's the future state of play and how we think the Cozy launcher is going to really fit in nicely to IBM's new architecture. We've got a Z196 running ZOS on our general purpose CPs inside of a job step. We still have the same IFL capabilities that we had before, where we run hyper sockets to allow communication between our Linux images on these IFLs and our job step. But we also have now a really new exciting capability, which is to use this IEDN to allow for clear channel communication across the backplane to a ZBX blade. Currently available, we have IBM has stated an AIX blade on power, and as a statement of direction, we know that Linux and Windows are coming on Intel 64-bit. So the launcher is going to be potentially a very, very important part of being able to distribute work from your ZOS system to these new blade extensions. I want to make another comment that one of the nice new features with the new architecture is that there's a set of very helpful and powerful APIs that are available to us as developers of the Cozy Toolkit to allow us to be able to check workloads and resource levels on these blade systems, so that by exploiting these APIs, we can make some changes to our Cozy launcher to potentially do load balancing and pick specific systems for running workloads depending on what kind of availability we have. So look for that as a future enhancement to Cozy coming sometime in the future. Okay, so we're just about finished here. I'm going to try to wrap up quickly. What are some of the benefits? You can manage remote processes on remote systems using ZOS Batch. One of the great things about this is that you can make use of open source technologies that are available on Linux but not available on ZOS Unix System Services just by using the Cozy launcher. And it allows you to expand your batch application workloads in the following ways: step-to-step flow control inside your job and dataset passing. You can make use of Unix pipes for process flow. We fully integrate cross-platform applications. It's easy to use, high performance, and secure. So we look forward to introducing you to this technology. Again, I want to point out that this toolkit is available. It's free to use. You can download it from our website, put it in place. You can use it under our community license. There's no charge to it at all. If you'd like to have commercial support, we do offer contracts for you that provide very good SLAs. As a final note before I completely wrap up, I want to point out that we also have available this OpenSSH accelerator for ZOS, which makes use of CPAC-F instructions if you have them available on your system to exploit hardware acceleration of the OpenSSH algorithms that do the encryption and key exchange in your OpenSSH environment. I won't go into a lot of details. It's another topic for another day, but depending on what you're doing, you can actually see a CPU reduction of 67% on your SSH workload by using this accelerator. So check our website or contact us directly if you want any more information. That's all I have. If anybody has any questions, we'd be happy to take them now. Otherwise, if that's enough, just go ahead and follow up with us by email or on our web.
Steve, I think we have a couple questions.
Okay.
Somebody says we spelled zap and zip wrong. Sorry about that. Little Z's, I guess. Michael wants to know if, let me see if I can expand this a little bit. Does SSH tunneling require allow TCP forwarding equals yes on ZOS? The answer to that is yes. If you're using the SSH tunneling, your SSHD server, the target system, needs to allow reverse TCP forwarding. That's actually how we allow the sockets to be tunneled back in the SSH connection. Some people, have some issue with that. I don't know exactly why, but I guess I think some people feel like turning things off is better if you don't know. In some cases, we have customers that might have an SSH server dedicated to Cozy that they have this enabled on another port. That's another option. But that is required on OpenSSH. Another question, is there any impacts using Cozy on IBM or ISV licenses on ZOS? I don't know why that would be. I can't imagine why that would be. No, I would say no.
Well, let's say this, though, Kirk. Let's be clear. If you manage to offload some of your work on a remote system and you thereby reduce the size of your ZOS footprint, then your license charges might go down for the software that you're currently running.
Right.
So I mean,
yeah, I guess that's that would be that could be the case, right? I guess that in some cases that's what you would be looking at. So I think that's all the questions. Make sure I didn't miss any. No, I think that's all the questions. I want to thank everyone for coming. Oh, wait a minute. Have another one. Is it possible to write output from a COBOL program to a name pipe that would effectively perform an SFTP to a remote system? I don't know. I think the question would be whether SFTP command itself would support name pipes. I think the answer to that is that, yeah, our Cozy SFTP client, I think, does support name pipes. So you should be able to do that in theory, although it's really unrelated to this. So. Oh, I think I have one more. No, that's the same one, right? Okay. Great. So I guess we'll thank you all for coming. And if you have someone else who would like to see this, I think we're going to try to put the slides and a recording up on our website. So check there in a couple of days. Thanks a lot.